Hello, time to make a new demo video, so let's just get started. So we open ShelXle and open a new structure. So let's see, it's here in documents, this one. So there is no structure yet, so we just use ShelXT to solve it. Here we go, there's the solution, and in this structure we have two phenyl rings, and often you have the problem that the data quality is not that optimal, and therefore you have to probably constrain that. First of all, we just rename that atoms, so we just use that auto-labeling structure now. So this has been done, and to fix those phenyl rings there is an AFIX command. It's called AFIX6 or AFIX66. So just typed AFIX66. And this means that the next 6 atoms should be in the geometry of a phenyl ring, and as we have 2 of them, I just put another AFIX66 here, and I have to close this AFIX thing in by AFIX 0. Like this, and I just define that. So they're fixed now, and we see there are some density effects everywhere, which caused because we refined it just isotropically, and those atoms move anisotropically, so we have to refine them anisotropically just by clicking here. So we see most of those effects are gone, and we see density everywhere for hydrogen atoms. So we just use the auto-AFIX command to fix hydrogens where the program thinks there should be a hydrogen atom. And what you can see here is this is the AFIX43 command for aromatic hydrogen, and usually hydrogen AFIX commands are closed with AFIX 0, and as there is a surrounding AFIX66, this 6.5 means that it's jumping back to that previous AFIX command. And the program has done this automatically in the right way. So you can just click on save and try to refine that. Seems to work. And we see the program is then able to find a hydrogen appropriate for that nitrogen atom, and we can see that nitrogen atom doesn't have a planar shape for that hydrogen atom, so we just click here right and choose the right option, so not the planar one, the non-planar one. So now it has added a hydrogen atom close to that Q peak found, so we can just refine that. So, and you see, yeah, there is really a hydrogen at the right position. To do that, ShelXle automatically uses defix commands and dang commands to restrain the position of that hydrogen atom. Yeah, so if we are not sure about that all these hydrogen atoms are placed correctly, there's a little trick. So I just changed the least squares to 0 cycles and use the omit $h command. This will preserve the structure as it is, but just computes the structure factors, now excluding hydrogen atoms. And now we can see that all our hydrogens place nicely inside of electron density made by those hydrogens. So everything is done correctly, so we can just comment that out and change that back to 10, so like this. So those density features are gone. As this structure is a quite high resolved structure, we see bonding effects, and also this AFIX command is a bit too strict for that molecule, so we see some strange red features at these atoms. So we don't need that AFIX in this part, so we just use the search and replace functionality and search for AFIX 66 has been found twice, so we replace that by nothing. So, and we want to get rid also of the 6,5 and change them to AFIX 0. So like this, and if I haven't done any mistake, this should refine very well. So I can hit space instead of clicking, and now we see those red features around those atoms are gone, and we just have the bonding effects of those double bonds or aromatic bonds in the phenyl ring. They're stronger than the others. So, and yeah, to finalize the structure, we just use the try to refine the weighting scheme functionality. This converged after 2 runs. Sometimes it doesn't converge at all, then it will stop after 10 runs. So now this looks quite good, and this was it for this video. Thank you for listening. Goodbye.